So here we have a question that asks, what composition of two rigid motions maps this black triangle ABC to this orange triangle A prime, B prime, C prime? So if I look at this and I look at where this black one is and I look at where this orange one is, I realize that if I were to just slide this over to here, it would be backwards, right? It would need to flip over in order to actually match up to what this shows me here. So that's why it's going to take two rigid motions. And this is going to be an example of what we call a glide reflection. A glide reflection is where we have a composition of a reflection followed by a translation in a direction parallel to the line of reflection. It's called a glide reflection, and these are examples of rigid motions because they're going to preserve the lengths of segments and the measures of angles. So let's look at it. What would we have to do flipping this over and then sliding it to get it to there? Well, I would look at this and I'd say, all right, first of all, I know I need to flip it over kind of this way, right? I need a line of reflection that's going to take this A and flip it to the other side of where it's at, right, compared to where C is, right? Because in the image down here, A prime is to the right of C prime, but up here in the original, in the pre-image, A is to the left of C. So I need to flip that A over to here. But then I need to flip it in such a way that it's going to be basically directly over A prime, B prime, C prime. What I need to have happen here is I need my shape my triangle ABC to end up right here. A, and then C there, and then B there. So that now with this triangle here, then all I have to do is slide it down to there, right? So my question is, what's the reflection that gets me to there, and then what's the slide or the translation that gets me down to there? Well, I look at where B is and where this new location for B, and I look, okay, I say those are 4 units apart. The C's are 4 units apart. The A's are 1, 2, 3, 4, 5, 6, 7, 8 units apart. And to find that line of reflection that's going to get me from there to there, and from here to here, and from here to here, I need to basically split that difference. So I'm looking at this and I'm thinking, I think my line of reflection needs to be halfway between where B is and where B started and where B ended up. So that would be right along here, right? It needs to kind of cross over there. And same thing with C and A, that halfway point between where they are in the black triangle and where they are in the blue triangle, that halfway point is right there. So if I kind of connect that, that looks to me like that would be my line of reflection. If I flip my black shape over that line, it would end up where I have it right here. And then I would just need to slide it down by how many? Well, the A needs to slide down 1, 2, 3, 4, 5. The C needs to slide down 1, 2, 3, 4, 5. And the B needs to slide down 1, 2, 3, 4, 5. Now they don't need to move left or right at all. They just need to slide directly down. So I need to flip it over my pink line and then slide it down by 5 units. And so the question is, how am I going to write this? How am I going to write this composition of two rigid motions? Well, first of all, it's a translation of a reflection, right? So I am going to translate something. I'm going to describe my translation here of the reflection along some line that I'm going to call M. And then I'm translating the reflection of triangle ABC, where M is the line. Well, what is that line of reflection, right? Here's my line M. That's the line that's vertical. It's a vertical line going through here, right here, -1 on the x-axis. So that tells me that line is x equals -1, right? So we're going to reflect, oops, I didn't mean to do that, sorry, I meant to grab my pointer. Here we go, we're going to reflect our triangle over this line M to end it up there, and then we're going to translate that. So we're going to translate that down by 5 units. So how do we describe a translation that goes down by 5? We say that the x is not changing at all, so we put a 0 there, and we put a -5 in that second number in the notation for a translation. So this is a translation by 0, -5 of the reflection on line M of triangle ABC, where M is the line, x equals -1. And that's our two rigid motions that takes this, flips it over to here, and then slides it down to here, and that's a glide reflection. So we can see in this problem we have a quadrilateral, ABCD, that we need to perform a glide reflection on. Our glide reflection is the translation by 1, 0 of the reflection along the x-axis. And so remember, when we perform glide reflections or any combination of transformations, we always want to start with the second one and then do with whatever that creates, we'll do the first transformation to that new shape. So for this one, we're going to start by reflecting our shape over the x-axis. And so to reflect a shape over its x-axis, or to reflect a point, we'll say, over its x-axis, we just move it from where it's at to the opposite side of the x-axis, the line of reflection, and by the same amount. So for instance, whereas A is 2 units above the x-axis, its new location is going to be down here 2 units below the x-axis. So that new location will be right there. B, we can see, is 5 units above the x-axis, so its new location is going to be down here 5 units below the x-axis. So I'll put a new point down here. And then D is going to go from 2 units below the axis to 2 units above. C is going to go from 4 units below to 4 units above. So now if I connect those into a shape, it's going to look like this. There we go. I had to think on that for a second, which points I was connecting. So now this new one, this kind of new shape here, is going to be my reflection of the original quadrilateral. And so now I just need to translate that by 1, 0. So translating at 1, 0 means I'm moving it a +1 in the x direction, but not moving at all in the y direction, a 0 in the y direction. So now I can look at this, I can say, all right, I'm going to take all 4 of those corners, and I'm just going to move them all 1 unit over in the x direction, and it's going to give me that shape. So this shape right here, KLIJ, is our glide reflection by this rule of our original quadrilateral ABCD. Now in this next problem, you can see I need to take this black triangle and map it to this orange triangle right here. So, and it's going to be a glide reflection, so we know we're going to flip this over and then slide it. So I need to think first, okay, how do I need to flip this? Do I need to flip it left to right? Do I need to flip it up to down? Right? And I look at where J and L are, and I notice that J in the image, in the orange one, J is to the left of L. And in my pre-image, J is also to the left of L. So what that tells me is I don't need to flip this left to right. I don't need to get J to be over on the other side of L. What I need to do is flip it like kind of top to bottom so that the K goes from being above where JL is to being below where JL is. So I need that K to slide down, or flip down to maybe like right here. So it's kind of even with where the K prime prime is. So I'm just going to kind of mark that. I want my K to end up right there. I want L to end up right here so that it's even with where L prime prime is. And I want J to end up right here. Oops, I didn't mean to mark those with 2 primes. Let me just take those off. There we go. So now what I'm looking at is I'm looking at trying to flip this black triangle, trying to reflect that black triangle to get it to these spots. So the question is, what's the line that it needs to flip over? And remember, to find that line is I want to look for kind of where is the halfway point between where the point started and where it finished. So where's halfway between where K started and where K prime is? And I noticed that that halfway point would be like right here. And the halfway point between L and L prime would be about right there. And the halfway point between J and J prime would be about right there. So if I connect those, I'll end up with a line that's like about right here. All right, there's that line of reflection. We'll call it line M that I need to flip triangle JKL over to get it to where the purple one is. Then from there, I can just slide it over, and it would match up with J prime, J prime prime, L prime prime, and K prime prime. I would need to slide it over by 1, 2, 3, 4, 5 units to the right. And if I did that 5-unit slide on each of the corners, it would end up right where this is. Okay, so how do I describe that? How do I describe those two combination of movements that I just made? What I'm going to say is I'm going to first talk about reflecting my triangle. Oops, I wrote that wrong. Reflecting my triangle JKL over line M, where M is the line. And then I need to think about, okay, what's the equation of this line that I drew here? All right, what is the equation of this line right here? And I notice that it's a flat line, a horizontal line that goes through +1 on the y-axis. Every point on this line is something, comma 1. It's 0, comma 1, or 1, comma 1, or 2, comma 1, or -5, comma 1. So that line there is the line y equals 1. So that reflection got the black triangle to be where the purple triangle is. Then I had to slide that over. So I need to add to my description here, I need to add a translation by 5, comma 0. And the reason I know it's 5, comma 0 is because I'm moving it 5 units to the right without moving it up or down. I'm moving all the corners 5 units to the right without moving them up or down. And so I describe that as 5, comma 0. This is the x direction that I'm sliding. +5 in the x direction, the left and right direction, but I'm not moving it anything up or down, so that's a 0 right there. So this would be the description of the glide reflection that would map triangle JKL to triangle J prime prime, K prime prime, L prime prime. Now in this last problem, it's asking us, does this glide reflection move triangle PQM to where triangle KJN is? So let's just kind of highlight a little bit what we're talking about here. We want to try and move triangle PQM, so I'm going to color that in with this kind of tealish color. I want to try and move this using this glide reflection. And I want to see if, does that put it where KJN is? Okay, so let's talk about this glide reflection. I noticed that it starts actually, it's kind of ordered in a little bit different fashion from what we've talked about. So we're going to start with the second transformation, right? A couple of the previous ones that we did started with a reflection. This one's actually starting with a translation because we start with the second transformation. It's a transformation where I'm moving 0 in the x direction, so not moving left or right, and then moving 4 in the y direction, which would tell us that we're moving up 4. So let's move all of these corners straight up by 4 units. Okay, so that's going to give us, P is going to move up by 4, so it'll be right here. Q would move up by 4, it would end up right here. And then M would move up by 4, so it would actually end up right here where N is, but I'm just going to label that as M prime. So that first part of that glide reflection moves me to right here. All right, moves me to this spot. So now the second part of it, it says that we're going to reflect over line N, where N is the line x equals 4. So let's sketch out where the line x equals 4 is on our graph here. The line x equals 4 is a vertical line going through 4 on the x-axis. It's connecting all the points that are 4, comma, anything. So like 4, comma 1 and 4, comma 2 and 4, comma 3 and all that. So that is this line right here. There's my line N, x equals 4. So now let me ask, when I flip this purple triangle over that line, where does everything end up? Well, M prime is on that line, so we know that in a reflection, any point that's on the line of reflection doesn't actually change its location. P would go from being 2 units directly to the right of that to being 2 units directly to the left. Oh, that would be at K. And then Q prime would go from where it's at here to 2 units to the left, which would be where J is. So it actually does look like that if I move those things to those spots, I'm going to have M still staying where it's at, P prime is going to go over here where K is, Q prime is going to go over here where J is, and I'll have triangle KJN. So it appears that yes, this glide reflection does map triangle PQM, which started out down here, to where triangle KJN is.